Section 9.2. Inferences about two means with independent samples. We will go step by step, explain the role of the degrees of freedom, and finish with a quick StatCrunch walkthrough. Notation. For population 1, we use mu1, sigma 1, n1, x bar 1, and s1. For population 2, we use mu2, sigma 2, n2, x bar 2, and s2. We assume the two samples are independent, simple random samples with unknown and not necessarily equal population standard deviations. Requirements. 1. The population standard deviations are unknown, and we do not assume they are equal. 2. The samples are independent. 3. Both are simple random samples. For either both sample sizes are large or the populations are approximately normal. Test statistic. Under the null hypothesis, mu1 equals mu2, the Welch t-statistic is x bar 1 minus x bar 2 divided by the standard error. The standard error is the square root of s1 squared over n1 plus s2 squared over n2. Degrees of freedom determine the shape of the reference t-distribution. Option 1 is the conservative choice, the smaller of n1 minus 1 and n2 minus 1. Option 2 is the Welch-Satterthwaite formula. In this formula, A is s1 squared over n1, and B is s2 squared over n2. Visually, smaller degrees of freedom give a heavier-tailed t-curve, and larger degrees of freedom move the curve closer to the normal curve. Watch how the critical value for 5% in the left tail shifts as the degrees of freedom increase. Testing workflow. 1. State the hypotheses. 2. Choose the significance level. 3. Compute the t-statistic and degrees of freedom. Forget a p-value or a critical value from the t-distribution with those degrees of freedom. 5. Make the decision and state the conclusion in context. Example. Are people getting taller? We compare the mean height from 1988 to the mean height from 2012 using independent samples. We test the claim mu1 is less than mu2 at alpha equals 0.05. Watch the computation of the test statistic and the degrees of freedom. First, compute the standard error. It is the square root of a plus b, where a is s1 squared over n1 and b is s2 squared over n2. Then compute the t-statistic as x bar 1 minus x bar 2 divided by that standard error. Now, the degrees of freedom. The conservative option is the smaller of 11 and 14, which is 11. The Welch-Satterthwaite formula gives a more accurate value, which here is about 19.4. These degrees of freedom change the shape of the t-curve and the critical value. Here is the picture. The blue line marks the critical value for 11 degrees of freedom. The purple line marks the critical value for about 19 degrees of freedom, and the white line marks the observed t-statistic. Because the observed t is to the right of both critical lines, it is not in the left tail rejection region, so we fail to reject the null hypothesis. The p-value is the left tail area to the left of the observed t. Using technology, with about 19 degrees of freedom, the p-value is approximately 0.0546, which is slightly larger than alpha equals 0.05. Decision. Fail to reject the null hypothesis. Interpretation. The sample does not provide sufficient evidence that the mean height in 1988 was less than the mean height in 2012. Confidence interval for mu1 minus mu2 uses the same standard error and the same t-distribution. For a 90% interval, the critical value is t sub 0.05. Using 11 degrees of freedom gives about 1.796, so the margin of error is that critical value times the standard error. The interval is x bar 1 minus x bar 2 plus minus the margin of error. Notice that 0 is inside the interval, which agrees with our test decision. Quick StatCrunch demo using summaries. 1. Open the stat menu. T-stats, to sample with summary. 2. Enter n1, x bar 1, s1, and then n2, x bar 2, s2. 3. Check do not assume equal variances. 4. Set the alternative to less than and set alpha to 0.05. 5. Compute. StatCrunch reports the t-statistic, the Welch degrees of freedom, the p-value, and the confidence interval. Your decision matches the manual work. Recommended strategy. Assume the population standard deviations are unknown and unequal. Use the Welch 2 sample t-test and its matching confidence interval. Always report the degrees of freedom, because they determine the critical values and the p-value through the t-distribution.